Welcome to the next session, my dear friends. In the previous session, we have discussed the concepts of treatment of sewage. Now, in this session, we are going to do all the previous GATE examination questions that are from treatment of sewage topic. Okay, so let us start with the first question. So it is GATE 1997 1 mark question 8.2 treatment of wastewater. So GATE 1997 1 mark question, that is question number 1. So in this question what he is saying, a typical biological process in treating wastewater using aerated lagoon can be described by one of the following schematic diagrams. Okay, so he is saying that aerated lagoons are used for the secondary treatment. Then what is a schematic diagram which is resembling the aerated lagoon process? Okay, so if you look at the aerated lagoon is nothing but, I have already told you in the previous lecture, so lagoons are nothing but we will dump all the waste water into the lagoon. Okay, whatever the sludge we will dump into the aerated in lagoons, it may be anaerobic or aerobic, whatever it may be. So in lagoons, so that will treat on its own either by aerobic bacteria. If you are providing aerators, then with aerobic bacteria it will treat itself, and finally so the whatever the organic matter will completely decompose and becomes manure, which we will directly use for the as a plant nutrients. That is what I have told you in the previous lecture. So here, so the aerated lagoon, after aerated lagoon, so there won't be any treatment is necessary to the wastewater. So directly we can use it like a manure. So that is why, so after aerated lagoon, no treatment is necessary. Directly the effluent can be used as a manure. Okay. Now if you look at these options, option A, the influent. See here what is meant by BR, what is meant by ST. So nothing was not given. So we need to assume suitably. Okay, we need to assume suitable names of it. AL is nothing but aerated lagoon, BR biological reactor, ST sedimentation tank. So likewise we need to assume, so because it was not even given what is the legend of these terms. So here from the sedimentation tank we are recirculating it into the aerated lagoon and the second option is influent to the biological reactor, and from afterwards it is going into sedimentation tank. Afterwards it is going into aerated lagoon. Here we are doing chlorination. See, if you look at this option, generally if you look at the proper aerated lagoons does not have any pre-treatment. Actually they does not contain any pre-treatment. So this system is not needed. Actually this system is not needed. The biological reactor and the sedimentation tank, from this sedimentation tank the sludge into the aerated lagoon, generally it is not needed. But if you want to reduce the BOD before sending into aerated lagoon, if you want to reduce the BOD before sending into the aerated lagoon. So we can have a preliminary treatment like any kind of biological reactor like trickling filter or activated sludge process, aeration tank, and afterwards we can send it into sedimentation tank. After the effluent we can send it into aerated lagoon. So after aerated lagoon no treatment is needed. So if you look at the options, choose the option where the aerated lagoon is at the last. If you look at all the four options, so aerated lagoon is kept at the last point only in the option B. So from the basic point of view, after aerated lagoon no treatment will be needed. So by looking from that point of view, okay, so aerated lagoon B is the option which is suiting more. And again, aerated lagoon does not, we do recirculation. In aerated lagoon we don't do recirculation also. So by looking that also we can eliminate option A and option D too. Okay, so that is why B is the answer, proper answer. B is the answer to this question. Okay, so let us move to the, actually in this question the data was not given properly, but anyways aerated lagoon, by looking at these options without knowing anything, so aerated lagoon is the last stage of treatment. So by knowing that concept also we can find the answer now without knowing any of these terms and all. Okay, so let us go to the next question, question number 2. Question number 2. Question number 2, GATE 2004, 2 marks question. GATE 2004, 2 marks question. So here the following data are given for a channel type grid chamber of length 7.5 meter, flow through velocity is given, and the depth of the wastewater at the peak flow in the channel is 0.9, specific gravity was given, and G is given, mu is given, rho W is given. Assuming the Stokes law is valid, the largest diameter particle that would be removed with 100% efficiency. See, this is only a kind of sedimentation tank problem only, but instead of sedimentation tank we are using the name grid chamber, but the concepts are one and same. Okay, so what is the given data? Let us extract the given data. The given data, so flow through velocity is equal to 0.3. That is, this is equal to Q by B into D. Okay, Q by B into D. That means velocity of the flow. So this is nothing but velocity of the flow. Now the depth of the water D is given. Depth of the water is T 0.9 meter, and the length of the chamber is also given. (7.5 meter). Specific gravity S is equal to 2.5, G is equal to 9.8 meter per second square, and mu is equal to 1.002 into 10 to the power of minus 3 Newton second per meter square. Rho W is 1000 kg per meter cube. So this is what given. So now first of all he is asking what is the diameter. Okay, what is the diameter? So what is the diameter means? So from Stokes law we know that Vs is equal to G into S minus 1 into D square by 18 nu, or G into rho S minus rho W into D square by 18 mu. So we have seen this, right? We have seen this. Now we know G, we know S, we know nu or mu, whatever it may be, rho W, everything we know. We don't know Vs, we don't know D. So Vs can be found from the efficiency part. Efficiency, it was given that efficiency is equal to Vs by V naught. So it is equal to 100%. That implies if you know V naught, we can find Vs. But V naught is also not given. Vf is given. So Vf, actually V naught is equal to Q by BL. Okay, Vf is equal to Q by BD. Now we know D value. So if you take this D here, so that implies Vf into D is equal to Q by B. Okay, Vf into D is equal to Q by B. So V naught is equal to Q by B into L. So Q by B I can remove. So this Q by B I can write it as Vf into D. That is Vf into D by L. Okay, that is V naught. So Vf is how much? 0.3. D is 0.9. This is L is 7.5. So by doing this we will get the V naught value. By doing that we will get the V naught value. So that V naught value will be equal to 0.036 meter per second. So this is the V naught value. So V naught value now we got. So this V naught value is nothing but Vs. Now this Vs value you will bring here and we will put all the data given and we can find the D from there. Okay, we can find the D from there. Now, so now Vs is equal to Vs, that is 0.0036 is equal to G 9.80 meter per second square, S minus 1, that is 2.5 minus 1 into D square by 18 nu. So this is mu. So nu is equal to mu by rho W. Okay, so mu is in Newton second per meter square. It is equal to 1.002 into 10 to the power of minus 3 by 10 to the power of 3. So that is equal to 1.002 into 10 to the power of minus 6. If you do this, Newton second per meter square by kg meter cube, so it will come meter square per second. It will come meter square per second. Okay, so that will be equal to meter square per second. So that is equal to 1.002 10 to the power of minus 6 meter square per second. So if you solve this, we will get the answer. If we solve this, we will get the answer, the diameter of the particle we will get. Here actually this conversion, again the conversion, very important. See, here the mu is given in Newton, meter cube per second. Okay, mu is given in Newton second per meter square. Okay, now first I need to convert this into kg, okay, kg second per meter square. So 1 Newton per meter square, so is equal to 10 kg per meter square. So here if I want to convert this into kg per meter square, then I need to multiply it with 10. I need to multiply it with here 10. So mu is equal to 1.002 into 10 to the power of minus 2 kg force second per meter square. This is kg per meter cube. So now this kg cancels. So if you go to the top, Newton second per 1 second. See here, 1 Newton meter per second square. 1 Newton meter per second square. Okay. So 1 Newton is nothing but force. Force is equal to mass into acceleration due to gravity. So this Newton is nothing but 1 kg. Newton is nothing but mass into acceleration, that is kg into meter per second square. So this is Newton multiplied with meter per second square. Okay. Sorry, meter square per second. So this is acceleration unit. 1 kg into meter per second square. 1 kg 1 Newton meter per second square. So this meter per second square is the acceleration unit. Sorry, small correction. Here the unit is Newton second per meter square. Newton second per meter square. So this is 1 Newton second per meter square. So what is Newton? Newton is nothing but 1 kg into acceleration due to gravity, meter per second square. So this is already present, second per meter square. Okay, so what is Newton? Newton is 1 kg meter per second square. Okay, so this is Newton. This is Newton and second per meter square. Now this second, meter, it get cancelled. So 1 kg per meter second. So this is nothing but 1 Newton second per meter square. This is nothing but 1 Newton second per meter square. Now I can replace it with this. Now 1.002 into 10 to the power of minus 3. Okay, Newton second per meter square is equal to 1.002 into 10 to the power of minus 3, okay, into 10 to the power of minus 3 here acceleration due to gravity value is 9.81, so here it will come 10. So 1 Newton is equal to 1 kg multiplied with acceleration due to gravity, that is 9.81, approximately it is 10. So here we need to multiply it with 10. Here we need to multiply it with 10 because I am converting this from Newton to kg. So here 10 kg per meter second, kg per meter second. So this is the conversion of the Newton second per meter square into kg per meter second, kg per meter second. So now here this is mu. So mu is equal to mu by rho w. So mu is equal to 1.002 into 10 to the power of minus 3 into 10, that is 10 to the power of minus 2 directly, 10 to the power of minus 2, 10 to the power of minus 2 kg per meter second by 1000 kg per meter cube. So this will be coming around 1.002 into 10 to the power of minus 5. So kg gets cancelled, so this meter will go up, it will become meter square per second. So this is the value of nu. This is the value of nu which we need to substitute in the solution. Okay, now we know the Vs value, we know the Vs value, and we know all other values. Simply substitute them, we will get the answer. Because, so why I am taking this much care in explaining the units? If you look at the options, there are two options. One is 0.21 and another one is 6.64. So you will get both the answers if you don't do the calculation properly. If you take nu as this, you will get 6.64. But this is wrong conversion. So proper conversion if you do, then you will get the proper answer, that is 0.21. So proper conversion is very, very important, especially in sedimentation tank and grit chamber, these kind of problems. So the conversion you need to be very cautious, otherwise you will lose a valuable 2 marks. So now Vs is equal to G by G into S minus 1 d square by 18 nu. Okay, what is Vs? We have got 0.036, G is 9.8, S is 2.5, minus 1, d square is not known, we need to know this, by 18 into 1.002 into 10 to the power of minus 5 meter square per second. This is, unit is meter per second square, it does not have any units, so it is here meter per second. If you solve this, you will get d as 0.00021 meter. So if you are calculating it in mm, you will get it as 0.21 mm. You will get it as 0.21 mm. So that is the solution of the second question, 0.21 mm. Okay, so let us go ahead into the third question. It is GATE 2008 2 marks question. GATE 2008 2 marks question. See, the conversion is very, very important. Again I am saying, so remember that conversion properly. Many problems you will face the difficulty in the conversion only. If you know the conversion, then these problems are very easy. So GATE 2008 2 marks question. It is a match the following question. So there is list 1 and there is list 2. So first one is primary treatment. And second one is secondary treatment. Unit operation. And unit process. And here contaminant removal by physical forces. Contaminant removal by physical forces. And option 2, involving biological and chemical reaction. Involving biological and or chemical reactions. And option number 3, conversion of soluble organic matter to biomass. Conversion of soluble organic matter to biomass. And option number 4, removal of solid materials from incoming wastewater. Removal of solid material from incoming wastewater. So these are the 2 lists given. Okay, two lists given. So in this we need to select the appropriate one. So if you look at this first one, primary treatment means what comes in primary treatment? We know that sedimentation, primary sedimentation tank comes in primary treatment. There we don't destruct the BOD, we only remove the BOD in the form of settlement. Okay, the solid material will settle, okay, inside the sedimentation tank, by which we can remove the BOD from that. Okay, so that is nothing but, if you look at this, so the A option will suits with this. So removal of solid material from incoming wastewater. Secondary treatment. So in secondary treatment we convert the soluble BOD. So whatever the organic matter, the soluble organic matter, so will be eaten by the biomass, and finally in that wastewater, all the organic matter will be consumed and biomass will left. Okay, so that will be soluble organic matter will be converted into biomass. That is nothing but the secondary treatment which we do in the secondary treatment. Unit operation. So I told you, if you are doing some kind of physical thing like settlement, screening, grid chamber, detritus tanks, all those things are unit operations. So contaminant removal by physical forces, that is nothing but unit operations. Unit processes means by means of biological and chemical means. If you are removing it, then it is called unit process. So from here we can easily write the answer. So option A is going to 4, B is 3, C 1 and D 2. So 4 3 1 2 is the answer. 4 3 1 2, option A is the answer. Okay, that is the answer for the third question. So let us go to the fourth question. So the fourth question, again it is also match the following. GATE 2009 2 marks question. GATE 2009. So there are two list 1, list 2. So here list 1 is grid chamber, and option B secondary settling tank, and option C activated sludge process, and trickling filter. List 2, 1 zone settling, and number 2 Stokes law. Number 3 aerobic, and number 4 contact stabilization. So these are the options given. So if you look at the grid chamber, just now we have did a question on grid chamber using the Stokes law concept. So generally grid chamber we use Stokes law, which is relatively suitable option. Secondary settling tank. See, I have told you different types of settling: discrete settling, hindered or zone settling, okay, or we can call it as a flocculent settling. So these settlings, okay, generally this zone settling we observe in the secondary sedimentation tank of water supply, where we use the flock. So there we will observe this kind of hindered. So when we don't add the flock, okay, so when the particles are very finer, then we will observe this kind of hindered settling. So hindered or zone settling we will observe when there are fine particles. So this is a kind of settling we observe generally in settling tanks only. So secondary settling tank is suitable for the zone settling. Activated sludge process and trickling filter, both are aerobic processes only. But the contact stabilization means the organic matter and the biomass will come in contact and stabilize. That is attached growth culture. That is nothing but a term called attached growth culture, is nothing but contact stabilization. So where we do observe the attached growth culture? So in trickling filter we observe the attached growth culture. So for trickling filter this is contact stabilization, and activated sludge process it will be the aerobic process. Okay, so for A it will be 2, for B it will be 1, for C it is 3, and for D it is 4. So this is the answer. So 2 1 3 4 is the answer. 2 1 3 4 is the answer. Question number 4, option B. Yeah, option B is the answer. So let us go to the next question, question number 5. GATE 2015 2 marks set 2. GATE 2015 2 marks from set 2. Question number 5, 2015 GATE, 2 marks, set 2. So, in a wastewater treatment plant, primary sedimentation tank designed to at an overflow rate of 32.5 meter cube per day per meter square is 32.5 meter long, 8.0 meter wide and a liquid depth of 2.25 meter. If the length of the weir is 75 meter, the weir loading rate. So here what is the given data? What is the given data? V naught, overflow rate is given. Overflow rate. Overflow rate is equal to 32.5 meter cube per day per meter square. This is overflow rate. And the length of the tank is length L is equal to 32.5 meter and width B is equal to 8.0 meter. Width is given 8.0 meter and liquid depth liquid depth H is equal to 2.25 meter. 2.25 meter and the length of the weir, length of the weir, that is equal to 75 meter. So what is the weir loading rate? Weir loading rate WLR in meter cube per day per meter. Okay, so now here what is weir loading rate? Weir loading rate is equal to total discharge by length of the weir, by length of weir. So this is what we have discussed. So here total discharge we don't know. We don't know the total discharge. But we know V naught. So we know the value of V naught. So V naught is nothing but Q by BL. So that implies Q is equal to V naught into BL. Q is equal to V naught into BL. So that means, so what is V naught here? 32.5 meter cube per day per meter square. So if you multiply it with the B and L, we will get the value of the discharge. Okay, so value of the discharge. So which is equal to V naught is 32.5 to B is 8.0, L 32.5. So here this is meter cube per day per meter square. Meter cube per day per meter square. This is meter and this is meter. So this is coming meter cube per day. So what is the value of it? What is the value of it? So then let us leave it for a while. So this is Q. So this is Q. Now this is Q. Now weir loading rate is equal to this Q by length of the weir, that is length of the weir is 75. So that is equal to 32.5 into 32.5 into 8 by 75 is the answer. By 75 is the answer. That is the weir loading rate and the answer is 112.667. 112.667 is the answer. Meter cube per day per meter. Okay. So we will discuss the rest of the questions in the next session. Thank you so much.